Hi all, welcome to the second part in this series on how to create your very own text editor in Go programming language. In this video, we're supposed to be creating an internal representation of the text buffer and provide a function that is supposed to be writing the content of that buffer to the terminal. But before we start, I'd like to fix some technical issue from the previous part. So it turned out that when I tried to run the code from the part 1 tutorial on Windows, well, not on Windows directly, but via Wine emulator, it turned out that it didn't work as expected. So I needed to alter the code a little bit. So here I have the copy of the previous tutorial, and I just say ego e.go to go into the code. So instead of just calling the poll event on its own, I actually do the loop here. So this is something similar to what we're supposed to be doing in the actual program, but I thought I could not include it, but it turned out that I had to. So I first create the event variable to store the poll event, and then if the type of the poll event is the key press, and if the particular key that has been pressed is escape, in that case we just break out of the loop and close the terminal. So this now also works on Windows as well. So to avoid confusions like this in future, what I want to do just right now at the moment is to create a simple build script that would be compiling both binary executables for Windows and for Linux, so that by the end of the video I could check whether it works on Windows exactly the same it does on Linux. So in order to do this, I can simply say ego and build.shell. And by the way, if you're on Windows and you don't want to make Linux executable, you don't really need to follow this. But I just make it because just going to be really useful. So I want to build Linux and Windows binary executables, let's just say binaries, and I say export Go OS equal to Linux and provide my build command. So I can say go build and -o output ego and the source file e.go, and then export Go OS equals to Windows and go build -o ego dot executable e.go and right quit. Now we need to make this file executable. Well, again, this is Linux specific things. I say chmod a+x and build shell, and now this should be, now it's turned green, which means I can now run it. So if I just say build shell, it now should compile both. And now if I go to, well, if I just run ego like this, now I need to hit escape to escape. That's the code from the previous part. And now wine task mgr, which is the task manager for wine, for Windows emulator called wine task mgr. Okay, so new task cmd, and here we go. So I just say ego.executable, and I got the output in my wine emulator, which works exactly the same. Okay, now let's get to the actual tutorial. So I now open the source file e.go, and let's kick start with creating a couple of variables. So I want to create two variables, rows and columns, both of type integer. So these would hold the width and height of the terminal, and also it would be possible to dynamically resize it so that if user resizes the terminal, the application doesn't crash. Then we need to provide the offset x and offset y, which these variables are supposed to be used for holding scrolling in future, but they already would have been involved within the display text buffer routine. So var offset x and offset y, both type integers. And now I want to create the text buffer. Text buffer is going to be the slice of slices, type row, so we're supposed to be storing Unicode characters in there. And just to display something on screen, I just want to populate this slice with some data. So let's say hello world here, like this. So just to make sure that I have something to display, actually. So hello. So I define every single character in separate, because that's the exact representation of how it's supposed to be done when it populates the text buffer from the file. World, hello world. Okay, good. So I can store it. And now let's implement the function to display this particular text buffer. So we have function display text buffer. This is the void function, not taking any arguments as well. So creating the variables row and col, which would store the current screen row and column we're supposed to be iterating over. So the type of integer. And now nested for loop. So for row equals to 0 and row is less than rows, the number of rows we have in our terminal, and then increment row plus plus. And the same for column. So for column is equal to 0, column is less than cols, col plus plus. Now the idea is that we need to select the proper frame within the buffer based on the x and y offsets, because depending on the scroll position of the variables responsible for that, we may see different parts of the entire text buffer. Well, obviously now it's quite small and we'll not see the difference, but when it comes to loading the actual data from the text file into the buffer, and when we would be able to scroll after implementing the scroll function, it would be absolutely essential to make sure that we display the proper part of the buffer. So in order to achieve this, let's create a couple more variables. So I want to create the variable called text buffer row. So text buffer row, and I assign the value to it of row plus offset y, and probably let's give it this name, a bit weird, but yeah. And then text buffer column is going to be equal to column plus offset x. So we're sort of translating the coordinates of the text we need to display from the absolute row column to the relative ones found in the buffer using these offsets. There is a bunch of conditions we need to check for to make sure that we are actually allowed to display the particular character from the text buffer. So I can simply say if text buffer row is greater equals than 0 and text buffer row is less than the len of the text buffer, and text buffer column, text buffer column is less than the len of the text buffer indexed by the text buffer row, right? And also, if this kind of works, then another condition. So we can say if text buffer and text buffer row and the text buffer column, so literally the character, the matched character, is not equal to tab. In this case, we print the character. So this is the idea of how to represent tab characters. So most editors actually do like replace tab characters with spaces. But since I'm not using tab characters and I don't want to complicate the source code, but still I want to be able to input tab characters. For instance, if I write a makefile in C for C project, I may need a tab, for otherwise it's not going to compile the file. But I just want to, I would be highlighting tabs with green background. So I just want to make sure that if I have a tab character in my source file, in that case, I can clearly see that it's right over in there. So, yeah, it's not Python, I'm sorry. So in this case, what we need to do is we can say termbox dot set char, so the function that I've been mentioning earlier, since we don't need to do any attributes, we're not doing syntax highlights in here. So just simply enough to specify the column, the row, then the text buffer indexed by the text buffer row and text buffer column. And otherwise, I want to say termbox dot set cell, and now we do provide the arguments. So here again, so we have the column, we have the row, convert to rune the space character, and then termbox dot color default for foreground, but termbox dot color color green for background, and this would just highlight the background of the tabs with the green color. Alright, so hopefully this makes sense. Now another thing we want to do, something similar to what Vim does. I want to print, well, I'm not going to be printing the tildes because it's not Vim, but I want to print asterisks if there are no lines in the source file. So to make this, I can say else if, and the condition is if the row plus offset y is greater than the length of the text buffer. In this case, I want to say termbox dot set cell. Again, set cell because I want to use the attribute here. So column 0, then the current row, then rune and asterisk here, and termbox dot color blue for the foreground, and termbox dot color default for the background. So after this, just say termbox dot set char, and at the current column and the current row I want to set the new line character. Let's run it as well, like this. Now let's go here down below, so we don't need this print message anymore for now, so just get rid of this. And now let's add some more code. So the first thing I want to do, I want to say calls and rows is equal to termbox.size, and this is needed for being able to like dynamically resize, and the terminal is not going to cause the crash of the text editor. So whatever current number of rows and calls we have would be initialized, and then we need to say rows minus minus, and that's because you see this magnificent status bar, so we need to preserve one line so that it later gets occupied by the status bar, so that's quite important as well. And another way to make it a bit more bulletproof, so I can say if the number of columns is less than 78, I will now explain why 78, then we want to set the columns equals to 78. So you can set this value to 80. The idea is that if this string doesn't have enough space to land in the very bottom line, it then results in error. So I need to make sure that there is always some space. And why? So by default it should be 80. And the reason why I use 78 is because to make this nice terminal you see in the video, like this bitmap mapping here, the width of this image is exactly 78 columns, not 80, so that's the reason why I use the 78. But you can obviously use like 80 here, so 80 instead of 78, that should be fairly good. Now the next thing to consider, we want to clear the terminal, so I can say termbox.clear. So then the attributes termbox, again color default, and termbox color default for backgrounds, for both foreground and background, right? And yeah, now we can display our text buffer, so display text buffer, and if I did everything properly, it should now compile and run, and we should see on the screen, we should see two lines. The first line should be hello, the second world. So let's make use of our build script. So I can simply say build, and if it builds, then I want to run ego. We'll run first the Linux version, no such file or directory, I'm sorry, build shell, right? Okay, undefined text buffer call, 23 text buffer call, just a typo. Okay, now it seems like it works. So we have hello the first line, world the second line, and yeah, that's exactly what we wanted to have here. And now let's check if this works exactly the same on Windows. So just press escape, and now again I say wine task manager, task mgr, and run the cmd, and try ego.executable. And yeah, so the hello world is good, but yeah, for some unknown reason it prints some strange stuff down below. Sorry guys, the reason why it didn't work is because we actually need obviously to do the following way. So first we close the if class to print this asterisk, and then every row we print a new line. So yeah, just the mismatch for this particular symbol here. Okay, and also length buffer -1, because that's the number of lines, because indexing starts with a 0. Okay, so now just to make this a bit more tight, I'll organize the code this way. All right, so write, quit, let's build again, and try it with wine. So wine task mgr, here we go, cmd, and ego. Yeah, and now we get exactly the output we want. So where the buffer is, we print something, then the asterisk, blue asterisk, and the very last line has been preserved. So this is the exact output we've been looking for. Cool. Now this is it from my side, guys, so catch you up in the next tutorial.